Hello, plants functioning under environmental stresses. Second classes, just to remind you what we did last classes. We planted our plants in greenhouses and we also took soil samples and today we'll analyze soil parameters. The first thing we will do, we will determine the amount of organic matter. For this we have to have a melting pot. The most important thing to remember is of course to label. The labels you can choose whatever you want. This is the clean soil, this is the soil contaminated with heavy metals, and additionally we also do tests from one soil taken just from the road neighborhood. So clean will take as clean. I will put C and 1 or C1 maybe, that's easier. So C1. That's also for control. We will do 2 replicates, so C2. For contaminated, C is taken, so we will take heavy metals, HM1 and HM2. And for road, to be simple, we will take R1 and R2. Of course, you have to take all the weights, so we will start with weighing the melting pots. C1, all in grams. C2, and for heavy metals, HM1 and 2. And the last pair for road, 1 and road 2. The melting pots are weighted, so now we have to add soil. Just to show you the differences, this is the soil taken from greenhouse. You can see it's full of organic matter, and this is the soil taken from road neighborhood. The structure is broken, very little of organic matter, sandy, mineral soil. That's clean. Done. And we have to do the weighing again. So I will start with control, C1. Done. And the last step, we have to place our samples into the oven. This oven allows us to burn the soil samples in temperature maximum 1300, but for our experiment we'll use maximum 550. Maybe important to notice that you cannot from the very beginning start with the highest, maximum temperature. You have to increase it gradually. I think, if I am not mistaken, we start with temperature 150 for yes. 3 hours, then 300
For another
3 hours, and 550 for 5 hours. So in total, the results will be tomorrow. Tomorrow we will do the final weighing. We just place it. Like that, and
what is that?
And start. We press start. Let's say done. Okay, we continue our measurements. We started with organic matter. Maybe just one sentence why we did determination of organic matter content. It's mostly because heavy metals can be strongly bounded to organic matters, and then they are less available for plants. For similar reason, we will do also pH measurements. In lower pH, metals are very active. If pH is close to neutral or alkaline, their activity in the soil is much lower, and then they are also safer for plants. We'll just do a short demonstration. Let's take a clean soil, and also maybe, because the difference should be big, the soil from the road. We will do it in simplest possible way. So we took beakers, 75 milliliters, 25 milliliters of soil, and then 2 parts of water, so up to 75. I will start with the soil. And also remember that you will have all the protocols in your system. You will find all the instructions and protocols. Clean soil. Approximately, of course. 25, and 50 ml of distilled water, and we have to stir. First sample done. And the road soil, or close to road soil. We will tabulate all the results in Excel file, and you will have it also in your HMS system. When all the data will be tabulated, we'll ask you to do all the calculations, which will be later needed for results evaluation. So the same approach: 25 ml of soil, 50 ml of water, stirring. Now, at least half an hour of waiting. During this half an hour, every 10 minutes, let's say, we'll have to do the stirring again. Just remember that we don't want to mix the samples. So when you mix one sample, clean the stirring, and like that. And after half an hour, we'll do the measurements. Okay, after half an hour, we'll do the measurements. We'll start with pH, then we'll continue with EC, electroconductivity, which allow us to know what is the salt concentration. electrode for pH. I just clean it because it's kept in femoral KCl. That's sample, the control sample for our heavy metal experiment. We'll just give it a while to stabilize. Okay, it's 5.6, which is pretty low. So from the very beginning we can say that the metals will be very active in our experiment, and most probably at the end of the semester we should see some negative effect of metals on plants. I will just write down the results. So 5.6 for control, and this is pH for a soil taken just from the road neighborhood, and here we expect it to be a little bit higher, but not much. It's just 6, let's say 6.10. We will send you a presentation from Dr. Mariola research, when you will see that in some places in Warsaw the pH close to the road can be even as high as 8. That result is low because this soil was taken from the meadow, under the meadow. So for us it's completely new location. We never studied meadows as a factors affecting pH, but it seems that they can keep the pH relatively low. So the pH is measured, and the second thing we will do, we will measure EC. We have to change the electrode. This I just dry because it's kept in distilled water. I have to change from pH to EC. When you measure EC, you have to be very careful with units. And now you saw the change from millisiemens to microsiemens.
1 millisiemens is 100 of microsiemens.
1000.
1000, sorry. 1000.
It should stabilize. The result is around 1. Oh, now it's up. Okay, I will write down approximately 1.7, which is equal to, that's millisiemens per centimeter, and that's equal to microsiemens per centimeter. Just for your knowledge and your further calculations, remember that we diluted our samples with 2 parts of water. It means that those results, to have a final EC, they should be multiplied by 3. So this EC is not impressive. It looks okay, optimal, but when you multiply it by 3, the result will be pretty high. Why? That's easy to say. It's because we have heavy metals there. The concentration of zinc, I guess, is higher than, we will have to also evaluate that, than 2000 ppm. That's why the EC is so high. And the same story for road sample. I need to clean the electrode carefully. And again, normally close to the road, because of the icing salt, you expect very high EC. But because this is from under the meadow, so flowering meadow, we don't really know what we can expect. And again, the result is pretty strange. Is low or very low. It's just 0.63 millisiemens per centimeter, or 630 microsiemens per centimeters.
It can be because the soil was prepared for
yes, maybe
for meadow
yes.
also.
And I don't really remember where also it was taken. If that was just close to the road, like this is the road, the sample, or in the middle of the meadow, 2-3 meters away from the road. This we don't remember, but it seems that the pH is very low. You will see in the presentation you will get for next classes. Classes related to this practicum, that EC also can be very high close to the roads, also based on the results from Dr. Mariola research. So now just cleaning. The last measurement for today, we will determine the concentration in fact of heavy metals. Just one example, soil taken from road neighborhood. We place the sample into plastic containers. One side is open, inert plastic foil, no heavy metals in composition. The equipment is called XRF. It's work like a X-ray spectrophotometer. The measurement is fast, pretty accurate, enough for our studies. We just place the samples over the X-ray emitter like that, with the inert foil down, facing the tool. We closed the box. That's safety because of the X-ray radiation. The measurement is very fast, takes a few seconds. You can see the light. It means that the measurement is done. And it's over. I just saved the data. Unfortunately, you cannot see the live results on the touchpad, but we will present you all the data in Excel spreadsheet, because you can export the results to Excel. Plant functioning under environmental stresses. We are finishing evaluation of our soil samples. So as you remember, we need to determine the level, the amount of organic matter in the soil. So those samples are already dried or burned. We have to weigh them. Wait. Before we start to weigh them, you can see the clear differences. So those are from heavy metals experiment. 2 of those are control, 2 of those are heavy metals contaminated soil, and this is soil from road neighborhood. So clearly you can see that the remaining area is much bigger. It means that this soil is mostly mineral, and those 2 are mostly organic. So I will just do the weighings. Okay, the weighing is done. We have all the data. We also did the pH and EC measurements for all the samples. We'll tabulate you the data, and you will get the Excel file or Word files, and your job will be to calculate the final results, the averages and the amount of organic matter in the sample.